Let us start with number 1. Okay, so log of 2 is equal to A. Log of 3 equals B. Now, you're going to have, on the test, I think you're going to have 2 or 3 of this kind of problem. Write log of, no, 2 problems. 2.7 repeating in terms of A and B. Okay, so the first thing you got to do is change 2.7 repeating to a fraction, just like today's quiz. Why am I saying that when Kwok didn't even take it yet? Change it to, well anyway, I told you guys the day before I was going to do that. So change that, how do you change this to a fraction? Well, we know that 0.7 repeating is 7/9, right? If not, just go home, cook rice, right? Come on, just like 0.3 repeating is 3/9, which is 1/3. You see a pattern. 0.1 repeating is 1/9. 0.2 repeating is 2/9. 0.9 repeating is 9/9, which is 1. Which always befuddles students, I don't know why. But you know 0.9 repeating is equal to 1 now. It's not approximately 1, it is 1. I'm still waiting for somebody to put that on the jersey. You know, if people want to be number 1, they put 0.9 repeating. That would throw off a lot of broadcasters. Okay, so this is 2 and 7/9. So what is 2 and 7/9? 25/9. So this is log of 25/9. So if you cannot even change it to a fraction, pretty much it's fatal error. Right? Now use your properties of logarithms. Isn't this log of 25 minus log of 9? Okay, and isn't 25 5 squared and 9 is 3 squared? Why do you write it with powers? So you can cough up the hairball in the front. 2 log 5 minus 2 log 3. Also, this one is B. Log 3 is B, Mr. Park, but log 5, I don't have log 5, I have log 2. Well, this is where the thinking comes in. What am I going to do? Who did this problem? Chai, what do you think? Huh? Oh, okay. Oh, yeah. Okay. Same thing. So, anyway, right here. So, what you got to do is you got to change 5 to 10/2. Why? Because you know what log 2 is. Log 2 is A, and log 10 is 1, right? Say what? Okay, look, using your properties of logarithms, log of 10/2 is log 10 minus log 2 minus 2 log 3. Right? So if you distribute the 2, you get 2 log 10 minus 2 log 2 minus 2 log 3. Well, what is log 10? What is the base that's not written? 10. 10 to the what power equals 10? 1. So that's just 2. Minus 2a minus 2b. And there's your answer. See, so you gotta think, of course, come on, if this is a test level problem, you're gonna have to think, right? It's always kicked up a notch. So anyway, see, when you take a test, you gotta minimize damage, at least get down to here. I don't know what to do with the log 5, at least write this as b, and then instead of getting minus 8, you get minus 4. Isn't that better? Okay, next. I don't know, let me guess. Number 5? These are the ones we usually do every year, since again, you still never wrote anything on the board. Nobody's gonna sneak up on him but got my back bearing, like you normally do. F of x equals ln of ln x. It says find the domain, no, not find the domain. When is f of x less than 0? Solve this inequality right here. Well, how do I get rid of this ln? You e both sides. So if you e both sides, what is e to the natural log badger? Less than, what is e to the 0? Wolverine. Okay, now, how do I get rid of this ln? You e both sides again. So e to the natural log iguana is iguana, and e to the 1 is tortoise. Oh, that was easy, Mr. Park. Yeah, but see, come on, this is a test problem. You think it's that simple? No. If you just did this on the test, worth 8 points, -4. Why? What did I do wrong? Because remember, when you have a natural log function, what about the argument? The argument has to be positive. So natural log x has to be greater than 0. That's the domain. And then how do we get rid of this ln? You e both sides again. So e to the natural log anaconda is anaconda, and e to the 0 is boa constrictor. So not only does x have to be smaller than e, it's got to be greater than 1. That's your answer. Come on, you know if it's on a test, there's got to be a twist to it, right? It can't be that simple. You can't just e both sides twice, right? I guess you can. That's why whenever you see a logarithm, you always have to be wary of what the domain is, right? The argument has to be positive. Okay, why do I keep looking at the board? There's nothing there. Okay, now let's look at number 7. On the test, number 7, you're going to have plenty of these now. You got to solve equations. Let me guess. B? Or no, B. Okay, 7B. Mr. Park, I couldn't do my homework because I had to do x log 3. Whatever, you gotta do what you gotta do, right? Okay, now one of these I can put the power in the front. Which one? Or can I do both? No, moose breath. This one, put the 3 in the front. No, fatal error. This is the one you can put the 4 in the front. So ln x equals 3. I mean, ln x cubed equal, put the power in the front, natural log x. And then if you want to make u substitution, u equals ln x. So you get u cubed equal 4u. Divide both sides by u. Don't you dare use solutions that way. Make ones, if the power is 2 or bigger, you make one side 0 and you factor. And look how nice it comes out. This is so pretty. U plus 2, u minus 2. No synthetic division needed on this one. So u equals 0, -2, and 2. Box that, that's the answer. No, a lot of you made that mistake on the quiz I just asked. Like, do not make that mistake. U substitution, you got to resubstitute back in. U is natural log x. So how do I get rid of ln? You e both sides. E to the natural log cobra is cobra. E to the 0 is 1. E to the -2 is just e to the -2, and e to the 2 is e to the 2, and there you go. Get 3 answers. Yeah, on this test, you don't want to make up your own. If you make up your own, that's a fatal error now. Like if you put the power down when you're not supposed to and things like that. You e both sides when you should have natural log both sides. Okay, D is U substitution. Okay, what about F? Every year we do F. I think we better do F. Okay, this is the problem that separates the goats from the sheep right here. Well, first thing I notice is, Mr. Park, I see logarithms. This one is base 16 and these are base 32. So what do you think is going to happen here? You're going to have to use the change base formula. Okay? So the first thing I do, I can put the 2 up as the power. Okay, now, let me write the change of base formula on the board so you can see what I'm doing. Log base b of a is equal to log base c of a over log base c of b, right? The top number goes on the top and the bottom number goes on the bottom. You guys are only used to going from here to here. But you got to be able to go from here to here. Also, you know, you got to be able to go back and forth. Just like when we study trigonometry next chapter. You cannot just know your identities one way. You got to know both ways. So watch what I'm going to do. This is the same thing as log base 64 of x squared. You guys see that? I went from here to there. keep staring. And then I'm gonna change the base. This is log base 64 of 2x minus 6. And then now look, they're both base 64. Now it's so easy. This is like today's quiz. Why did I say that with popcorn ticket? So now you just use your properties of logarithm. So when you subtract, you're going to divide the arguments. How do I get rid of a log base 64? You 64 it. You 64 it. So 64 to the log base 64 of anteater is anteater. 64 to the 1/2 is velociraptor. And then come on, this is algebra 1. Cross multiply. 16x minus 48. So x squared minus 16x plus 48. This is the easy part now. It factors nicely. What is that? 6 and 8? No. 12 and 4? Yes. X minus 12, x minus 4. So x equals 12 or 4. Box set, that's the answer. No, you gotta check. Now remember, this was the original problem. So whenever you have a logarithm, this thing and that thing have to be positive. If I plug in both 12 and 4, do they both come out positive? Yes. No, they're both the answers. Because if one of these make one of the arguments negative, you gotta cross it out. But they both work. Number 9. Hyperbolic cosine. What is that again? Did you guys tell your physics teacher? It's the hanging chain. Hanging chain. Hyperbolic cosine. Anybody? Anoka?
I'm not in physics.
You press your chemistry teacher then.
I'll try today.
Okay. They probably slap your head though, right? Number 9. For what values of x is the hyperbolic cosine function equal to 2? Okay, before we even start, how many answers are there going to be without looking at the bottom? 2. How do you know? Because the hanging chain. Remember, didn't we graph this as one of the homework problems?
Yeah.
Didn't it look like this? Of course it goes up. This is the hyperbolic cosine function. Okay, and then what does the graph of y equal 2 look like? This was 1 here, so here's 2. How many times did it intersect? 2, right? When is this equal to 2, right? There's 2 times when the y coordinate is 2. So that's what we're trying to find. So there's going to be 2 answers here. Okay, now hyperbolic cosine on the test, so like you don't have to memorize all the formulas. Like on the test, like this one, you don't have to memorize this. I will give it to you. Hyperbolic cosine 2, sine, and you don't have to memorize. I'm going to tell you. Hyperbolic cosine is e to the x plus e to the negative x over 2. Okay, I'll tell you that. So basically, you got to solve this equation. Do I know how to solve equations like this? Yes, we did this on expo log 1 even, right? In fact, I think I had one of today's quiz. Why am I saying that? E to the x plus e to the negative x equals 4. Cross multiply. Now what do? I think this is like the 3rd or 4th time we've seen this problem, this chapter before. U substitution. U equal. Anytime you see an equation like this, it's going to give you a quadratic. This is u. This is 1 over u equals 4. If you multiply both sides by the least common denominator, which is not 4u, but u, you get u squared plus 1 equals 4u. That's quadratic, so you make one side 0. And it doesn't factor now. Remember I told you it's not going to factor now. I got to use quadratic formula. So if you use the quadratic formula, you're going to get, don't tell me, 2 plus or minus root 3. Box that, that's the answer. No! Your substitution was e to the x. We're solving for x, not u here. So how do I get rid of e? You natural log both sides. So natural log of e to the armadillo is armadillo, right? And natural log of this is just natural log of that. And are both of these numbers positive? Because you cannot have natural log of a negative number. Yeah, 2 minus root 3 is positive, so these are your two answers right there. So those, and like I told you, we're supposed to have two answers, right? Before we even start the problem, you know. What if I gave you this problem on a test, which I did last year, I think? Hyperbolic sine is equal to 2. How many answers are there going to be? 1. Because when we graphed hyperbolic sine, didn't it look something like this? Yes. So how many times is the y-coordinate 2? Right there, only once. So now I'm only going to have one answer. It really, you don't have to know that. You can just solve the equations. Okay, and then what about, what about C? Everybody can lomi, huli if necessary. You sure? That one's not that obvious, you know. Okay, C and D. Okay, here we go. 8C. Limit as n approaches infinity, n times natural log of n plus 3 over n. Okay, first thing, if you have a logarithm, what can you do with this thing in the front? Put it up as the power 8. It's starting to look like something. Okay, so what do I do? What do I need to do here? Lift and separate. So 1, n over n is 1, 3 over n to the a. This thing right there. I know you. 1 plus box over n to the n. If you take the limit as n approaches infinity, that gets closer to what? E to the third, right? E to the box. So this gets closer and closer to e to the third. That's the way we write it in mathematics. So what's the answer? What's natural log of e to the third power? 3. The natural log of e to the gorilla is gorilla. And then D, limit, as t approaches infinity. Okay, a, b, and c are natural numbers now. 1 plus a e to the negative bp. Okay, what happens? We talked about this when we did the logistic growth graph, remember? What happens to this as t approaches infinity? What happens when you plug in a super huge number for t, like a billion? You get e to the negative huge. That means 1 over e to the huge. Isn't that getting closer and closer to 0 then? Okay, so if this gets closer and closer to 0, then the whole thing gets closer and closer to c. And then the factoring problem. Yes, there's going to be a factoring problem on the test. So did you guys practice that? Or and then if there's another one, it's the next one. Okay, the bell's going to ring already. So tomorrow, last chance for questions. Hopefully this is all sinking in. Yep, I see a factoring one right there. Oh, wait a minute. Nobody even asked about expo log 4 number 2? Everybody got, yeah, everybody got that. Oh. Hope we don't get a fatal error on the test. You guys better ask tomorrow.